Hi, welcome back. In this video, we are going to look at inverse relations. When we're talking about inverse relations, we're going to be looking at a relation F and its inverse F inverse. We write inverse with a -1 exponent on the function or the relation name. So the definition of an inverse is the set of ordered pairs obtained by exchanging the coordinates of each of the ordered pairs of the original relation. The domain of a relation becomes the range of the inverse. The range of the relation becomes the domain of the inverse. In other words, the input of F becomes the output of F inverse. The output of F becomes the input of F inverse. Another way of saying this is if F and F inverse are inverses, then F of A equals B if and only if F inverse of B equals A. Let's look at an example of how we use this. So in this example, it says, state the domain and range of the relation, find the inverse relation, then find the domain and range of the inverse relation, graph A and its inverse. So to start, I want to write the domain and range of A. So I am going to write this as the domain of A. And remember, the domain is the X values or the inputs. So this is 1, 3, and 6. And the range of A is the output or the Y value. So that is 5, -2, and -1. I'm actually going to go ahead and graph these points right now just so that I can get that out of the way. So 1, 5, 1, 2, 3, 4, 5. 3, -2, 1, 2, 3, -2. And 6, -1. 1, 2, 3, 4, 5, 6, -1. All right. Now, to find A inverse, I need to take each of the ordered pairs and flip them. So if I have an ordered pair A, B for F inverse, it will be B, A. So I'm going to take each ordered pair. So 1, 5 in relation A becomes 5, 1 in relation B, or in relation A inverse. 3, -2 becomes -2, 3. And 6, -1 becomes -1, 6 in A inverse. The domain of A inverse is just the X values. So that is 5, -2, and -1, which if we look at the domain of A, it's the same thing as, or the domain of A inverse is the same thing as the range of A. And the range of A inverse is just the Y values. So that is 1, 3, and 6. The range of A inverse is the domain of A. Beyond this, I'm now going to graph A inverse. So I have 5, 1, 1, 2, 3, 4, 5, 1, -2, 3, -1, 6. One thing that we can kind of start to see here, not only is the domain or the domain and range of the two different, of the inverse and its original relation related, but if I graph the line Y equals X, you can see that each of these points is mirrored across the line Y equals X. So the inverse relation is the mirror of the original relation across the line Y equals X.